Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid and my metric number is CE180162. Right now, I'm going to present about my final year project presentation. My title is Multi-Camera Cartoon Boxes and Pallets Tracking for Rail Guided Vehicle, RGV and Roller Conveyor System. And my supervisor name is TS Dr. Muhammad Nuzali bin Haji Muhammad. Next is about the problem statement. Project background. Project background. In an era of significantly development technology, the management of raw material or basic material of a product in the manufacturing sector in particular requires a technology that enables a plant to operate properly, safely and achieve the goal set by the factory organization, especially in the distribution, delivery, packaging of basic or raw materials. It needs to be done quickly, accurately, and safely. Therefore, the back conveyor and RGV system is needed to overcome any problems that can reduce human loads in terms of time, distance, weight, and even the amount of material that needs to be moved. This paper discusses the design, preparation, and consideration of the back conveyor system in terms of size, length, capacity, and speed. That's for project background. Next is problem statement. Multiple object tracking has a wide range of applications including zero, surveillance, and robotics. In this paper, we broaden the application field to include automated conveyor system. Inspired by video surveillance tracking method, use an online tracking by detection approach based on background subtraction logistic application proof to be a difficult scenario for existing methods. This is a multiple challenge. For starters, conveyor objects have a similar appearance, making conclusion handling difficult. Second, they are frequently stationary, making them difficult to detect using background subtraction techniques. That's for the problem statement. The next, objective. The first point is to capture, track, and record pallets and cartoon on the RGV and roller conveyor belt. Railguided vehicle (RTV). And the next objective is to research and develop a computer vision system on conveyor lines for products routine analysis and error detection. The third point is to obtain the same product on conveyor lines to begin point to end point. Lastly, to avoid human error and reduce human workload in the maintenance. Next is the project scope. This project will cover several scopes of development. This to research and develop a computer vision system to capture, trace, and record the movement of pellets stacked in with cartoons traveling on roller conveyor and RGV. Rail guided vehicle line from begin point to end point for product routine and analysis and error detection. Next is the methodology. In this project, the manufacturing process of work in process is described and presented by trajectories with manufacturing significance in a data-rich manufacturing environment. Advanced approaches for work in process trajectory data analytics and prediction, on the other hand, are woefully inadequate. However, in the manufacturing field, location prediction of moving objects has received a lot of attention. However, most approaches for predicting future location of objects were developed in the geography domain. When applied to the manufacturing shop floor, the prediction results are unreliable. This article this article focuses on predicting the next work in process location in the workshop. To begin, a data model is introduced to map geographic trajectory into logical space in order to convert manufacturing information into logical features. A prediction method based on the data model is proposed to predict the next location using frequent trajectory pattern. To test the prediction method, a series experiment must carry out. The experiment result demonstrate the effect of the user-defined factors and demonstrate the effectiveness and efficiency of the proposed method. These are the camera model suggestions, which are brand Dahua technology, model DHIPC HFW3549EP AS LED. This camera has 5MP full color fixed local warm LED bullet wind sense network camera. It has image sensor low and has low illuminance high image definition. The output max is 2592 times 1944 or 20 fps and support 4MP. High compression rate, built-in warm light, max illumination distance 30 meter. Okay. Next is the literature review. Okay, in this literature review, it covers reports, papers, articles, and journals that have been written and published on a computer vision which type trajectory. This acts as a guide in setting up this project. This will give a better understanding of the system and its design. The proposed project consists of various order of computer vision analysis with the trajectory and will explain all the equipment about the conceptual background and present the study of previous research about the computer vision. It consists of sort, which is a simple outline and real-time tracking, deep sort, YOLO, or CNN, and the study of previous related project. Many research work have been done on the multi-camera live board tracking for convey system like Xinyu Hao, Yi Wan, and Lep Pu Chao proposed to incorporate low confidence thread filtering into the simple outline and real-time tracking with a deep association metric deep sort algorithm. A self-generate UA-detract vehicle re-identification dataset can be used to train the convolution neural network of deep sort for data association. The proposed tracker evaluates on UA-detract test dataset. Also, Othman N. A. Salur and U. Karakus M. and Aydin stated that the detection is improvised in algorithm part through utilizing morphological operations since noises are eliminated. Therefore, the shape is smoothened and by enable the outline size of each project differentiable. Also, Yosra Dorai, Wantu Sami Gaza, Frederick Causes Najwa Asaukri Ben Amara, determining whether the same object appears in a different place at a different time, captured by another camera. In this paper, triplet style transfer and part level feature description for a person re-identification in a camera network. They propose a novel track like this approach for re-identifying objects despite the illumination condition differences that occur at various times of day. A similarity search is performed by comparing part-level object features descriptions. Tracking in each camera is made by recurrent neural network, and the matching between cameras is done by using similarity neural network to obtain an input in the form of a similarity score. Next is expected result, and lastly, based on the research that will be done, the predict outcome of the project is that important in the research and develop a computer vision system to capture, trace, record the movement and predict stacked cartoon traveling on roller conveyor and RGV rail guided vehicle lines from begin point to end point for product routines analysis and error detection. Stationary object detection. This is a well-known problem with background subtraction method, the adaptation process of background subtraction technique, where pixels of stationary objects are progressively included in the background model. Causes uh, causes the absorption of moving object that become motionless, as you figure in the slide. This issue has a significant impact on tracking performance in the logistic scenario, because conveyor object may be stopped for a short period of time of routine purpose. In this paper, we propose a feedback loop from tracking to rejection with the goal of stopping the adaptation process for region corresponding to stationary objects. We extend the original idea to several state-of-the-art background subtraction technique, which was presented. We demonstrate significant improvement in tracking result in a real-world video sequence. Okay, I think that's all for my presentation. Thank you.